Hello, my algebra people. Let's get started with today's notes. Today we're talking about the fundamental theorem of algebra and rational root theorem. Your learning target for today is that you can use the fundamental theorem of algebra. Well, we're gonna do this part first, and then we'll do this part next. So just for right now, fundamental theorem of algebra. I can use the degree of the polynomial to determine the number of roots. Let's talk about that word degree. When we say degree, we mean the highest exponent. So when we say the degree, we mean the highest exponent. And the highest exponent can tell us how many roots there are. Now, when we say roots, what are we talking about here? Zeros, solutions, x-intercepts. These are all words that are interchangeable. They all mean the same thing, x-intercepts. So if we were to graph a polynomial, we could look at the degree and see how many roots there are. Remember, the degree is the highest exponent. Okay, then we can find the linear factors of the polynomial. We know what factoring means. Factors, that's referring to the parentheses, where usually there's an x here and some number here, a plus or minus, and these are your factors. We found these in multiple ways using factor by grouping or the ABC method. We can also factor using those little tricks that we talked about the last two lessons, sum and difference of cubes and sum and difference of squares. Last, we can solve using the zero product property. Now, all that is setting the parentheses equal to 0, or setting the factors equal to 0. All right. And one more thing I want to mention here before we get started, we are going to be dealing with I just a little bit. So as a reminder, the square root of a negative number is equal to the letter I. All right. So we're going to be following these steps. These three steps right here are kind of all in one. So don't think that these are all different steps here. These three steps are kind of all in one. So we go from step 1, this is like our step 2, and then step 3. So first step is to set the polynomial equal to 0. Bam. All right. Step 2, factor using GCF or by grouping. Here we have 4 terms, and we know 1, 2, 3, 4. When there are 4 terms present, we don't need to factor using ABC. We can factor by grouping, right away going straight into the grouping. So looking at the first group, what can we factor out of this group? We'll factor out an x squared. And from the second group, we have a positive number in front, so the number we factor out is going to be positive. Between 6 and 4, our GCF is 2. Now, that is going to be our first set of parentheses, x squared plus 2. Our second set we get from dividing. So we're going to take 6x divided by 2. That leaves us with 3x. And then we have 4 divided by 2, which leaves us with 2. Now, the next step is to use the zero product property to solve. And what this means, again, is to set parentheses equal to 0 and solve for x. So first set of parentheses, x squared plus 2. Let's set that equal to 0 and solve for x. Now we have to take the square root right here. Cancels out the 2, the exponent, but it leaves us with x equals the square root of a negative number. As I reminded you in the beginning, the square root of a negative 1 is I. Really, square root of a negative number, we're going to use I. So here we have the square root of negative 2. Well, we can't take the square root of 2 without getting a decimal. The square root of a negative is I. So our answer is going to be x equals, x equals plus or minus I square root of 2. We should also make a mental note on the top of our notes somewhere that the square root of a number gives you two solutions. It gives you a positive and a negative solution. So when we take the square root of 2, we mean the positive square root of 2 and the negative square root of 2. Now let's set the other parentheses, the other factor, equal to 0, and solve for x. All right, so now here we have x equals negative 2 over 3. Now our roots, we have 3 roots here. Even though it looks like there's only 2 here, there's 3 because on the left we have a positive I square root of 2 and a negative. So if I wanted to write my answers all together, I could say, let's not do a set, let's just say x equals positive I square root of 2, negative I square root of 2, and negative 2/3. Those are our answers. Those are our roots, our solutions, our zeros. So if I were to draw a graph, these points on the x-axis is where we would find our polynomial touches or crosses the x-axis. All right, let's take a look at this third example right here, or second one, sorry. And here we have two terms. We have a 9, which I know is a perfect square, and a cube. Well, 9 is not a perfect cube, so we don't have a difference or sum. I'm sorry, we don't have a sum of cubes or squares here. But both terms do have an x. I wonder if we could do factor by grouping. If we were to add a 0 as our c value, and we did a t-chart, that means 0 would go on top and 9 would go on the bottom. Now, looking for factors of 0, anything multiplies to 0. But I guess factors of 0 that would add up to 9 would be 9 and 0. 9 times 0 is 0, and 9 plus 0 is 0. That's kind of ugly. I can see an easier way where we could do this. Here, both terms have an x. So we can factor this using GCF. And let's read back step 2. It says factor using GCF or by grouping. Now remember, grouping is when we do this and we do ABC. Sometimes we do ABC. And factoring GCF is just looking at all the terms and determining what can be taken out of all of them. What is our GCF here? And in this case, our GCF is x. So if we were to factor out an x, it's really like we're dividing by x here. If we were to factor out an x, we'd be left with x2 plus 3. These x's cancel out, and these become square. All right, so we have factored out the GCF. Now, moving on to our next step here, step 4, use the zero product property to solve. And again, that's set the parentheses equal to 0 and solve for x. Now here we do have an x in front, and we will set that equal to 0 as well. So x equals 0 and x squared plus 0. This is already solved. We know one of our roots is at 0, at the origin. And here, let's solve. Now we need to take that square root of both sides. And x equals, it's the square root of a negative number. We can't take the square root of 3, so it's going to stay plus minus I square root of 3. Now our three roots, we have two roots here, plus and minus, and 0. So our three roots here are going to be x equals 0, positive I square root of 3, and negative I square root. All right, moving on to the next question. Here we have g of x equals x to the 4 minus 16. So, okay, let's go ahead and see what we can factor out. We have x to the 4 and 16, which are both perfect squares. So this here is going to be a difference of squares. And if you need the formula for that, check your notes. They're in a few pages before this. All right, so when we have difference of squares, I like to take the square root of both terms. The square root of x to the 4 is x squared, and the square root of 16 is 4. Now we can go ahead and write our factors, x squared plus 4 and x squared minus 4. All right, now, are we done here? Unfortunately not. Oops, we have a little bit more to go. We again have perfect squares. X squared is a perfect square and 4 are perfect squares. So this is difference of squares, and this here with the plus sign is sum of squares. And when we use sum of squares, that's where the I comes into play. Otherwise, the formulas are exactly the same, but sum of squares uses I. So the square root of x squared is x, and the square root of 4 is 2. So let's write our factors. X minus 2i, x plus 2i, and for the difference, we just use same thing, no I. All right, now we're done factoring here. We can't go any further. Our next step is to use the zero product property and solve, which means set all the factors equal to 0. All right, so we're going to say this is now x minus 2i equals 0. This is now x plus 2i, 0. Go ahead and continue with the others as well. Oops, I'm realizing I made a mistake. I'm so sorry. I said not to use I here, and yet I still used I. So hopefully you caught that. There we go. Yes, because what I said was that difference of squares does not include I, but sum of squares does include I, so we need that. All right, now we have everything set equal to 0. We can go ahead and solve by adding or subtracting the term to the other side. All right, now that we have all of our factors set equal to 0 and solved for x, we know that we have 1, 2, 3, 4 roots here. X equals negative 2i, positive 2i, negative 2, and positive 2. 4 roots. So if we wanted to ask you what degree is this polynomial has a degree of 4. There are 4 roots, so the degree is 4. All right, now question. Do you have to write all of this math? All of this here? Really? No, you don't. If it makes you happy, if it makes you feel good, then by all means do it. But do you have to do it? Am I looking for that on a test? No. What we've talked about multiple times is that x lies. So x is with negative 2i, but really he's with positive 2i. Okay, so if you can look at these and remember that x lies, you know that when you solve for this, you're just going to subtract that over and it's going to become negative. Then no, you don't have to do all this work. Now, if that is not something that that you're able to process, that's totally okay. Do the work. Do it every time until you're comfortable with it. Oops, erasing too much. We'll just leave it there. All right, so let's go ahead and try this example. Here we have 4 terms, and the 4 terms tells me we need to go right into grouping. Now from the first group, what can we factor out? What is our GCF? X squared. From the second group, we have a positive number, and our GCF here is 9. So starting to write our factors, we're going to say x squared plus 9. And the second set of parentheses we find by dividing. 9x divided by 9 leaves us with x, and 45 divided by 9 leaves us with 5. Now, we have our 2 factors. We've already factored, but are we done yet? Heck no, we're not. Right here, we have 2 perfect squares, x squared and 9. It's a positive, so that tells me it's sum of squares. And what special letter do we need when we are calculating, or I'm sorry, factoring sum of squares? If you said I, you are correct. So here we're going to take the square root of x squared and 9, leaving us with x and 3. Now sum of squares, we just say x plus 3 and x minus 3, but with the I on 3. This x plus 5 will just come down, and he's just hanging out. Now that we have our perfectly factored form, this cannot be factored any further. We are going to use the zero product property to solve our final step. So again, we're setting these parentheses equal to 0 and solving. Now, yes, you can say x plus 3i equals 0. X minus 3i equals 0. X plus 5 equals 0. But I know when I add or subtract these items over, all that's going to happen is the sign is going to be different. All right, so here's our 3 roots. So there are 3 roots, and this means the degree is 3. So we can say x equals 3i, negative 3i, and negative 5. All right, let's take a look at the back side. Okay, here, now we're talking about the, what did we call it? Rational root theorem. Your learning target is that you can write the equation of the polynomial given the roots. Oops. 1 second. Okay, sorry. My alarm was going off. All right. So again, this is rational root theorem, and it says I can write the equation of the polynomial given the roots. So here we're going to be working backwards. On the last page, we took the polynomial and found the roots. Now we're taking the roots and finding the equation of the polynomial. So starting with the word equation, when we say equation, we're talking about an equal sign is present. Again, when we say roots, what are some words for roots? Zeros, solutions, x-intercepts. All right, so our success criteria says I can use the number of zeros, roots, solutions, x-intercepts to find the degree of the polynomial. We just did that on the last one. We found the roots, and we were able to determine the degree. Well, we're going to do that now, but here, let's look back at this example. I said the degree is 3. We had 3 roots. Look at our degree. The highest exponent here is 3, so we were correct. Here, our highest exponent was originally 3. Look at our roots. 1, 2, 3. 3 roots. Here, our degree was 4. How many roots do we have? 4. And I said exactly degree 4. Here, what is our degree of this polynomial? Highest exponent, 3. How many roots do we have? 1, 2, 3. So we were given the polynomial, we looked at the degree, and determined the number of roots, which happen to be the same number of the degree. Now on these, we're going to be working backwards, like I said. So we're being given the roots, and now we are going to determine the degree based on the roots. And we're also going to find the equation of the polynomial. So we can use zeros to write the factors, we can multiply the factors, and then write the polynomial in standard form. As usual, these are steps. 1, 2, 3, 4. All right, so starting with example 1. Here's our steps to the side. It says identify how many zeros there are. How many zeros are here? 3. Yeah, there are 3 zeros. So what do you think the degree of our polynomial is going to be? If you said 3, you're right. So next says identify the degree. We did that. Write the factors in the following form. So it says f of x equals x minus r1. That's our first root. X minus r2 and x minus r3, and then continuing on depending on how many roots we have. It says r1, 2, and 3 represent the roots of the equation. Then we will multiply the factors and get the original equation. All right, so here we have 3 zeros, 3 roots, which means degree of 3. This is going to be our root 1, root 2, and root 3. Let's use this formula. We're going to say f of x equals x minus 0, just like the formula, x minus 2, and x minus negative 3. So the reason we're using minus is because the formula calls for minus, but here we have a negative 3. So really we're saying x minus negative 3. And what happens when we have that double negative? Double negative makes a positive. So now we have our formula, but here we have x minus 0. Subtracting 0 doesn't change x at all. We're taking nothing away. So we don't write minus 0. We say x times x minus 2 times x plus 3. Now we can multiply everything out. So we're going to start with the parentheses. X times x is x squared. X times 3 is 3x. Then we move on to the negative 2. Negative 2 times x is negative 2x. And negative 2 times 3 is negative 6. Now, don't forget about that x that was in front. Now we need to distribute that x to all 4 terms. Multiplying x to x squared, we get x cubed. X times 3x is 3x squared. X times negative 2x is negative 2x squared. And x times negative 6 is negative 6x. Now you should see that these middle 2 terms are both x squared. We can go ahead and combine those. If you combined them up here and then distributed the x, that's totally fine too. We'll all get to the same place. So 3 minus 2 is going to give us just 1x. So f of x, our original function, is x cubed plus x squared minus 6x. Let's look at that degree. Our highest exponent is 3, just like we said it would be. There were 3 zeros, so our degree is 3. Okay, Now, still following the same steps, there is a note here about the complex conjugate root theorem. It says if a plus bi is a zero of the polynomial, the conjugate a minus bi is also a zero. So we cannot have one complex root without the other. So if we have a minus bi somewhere, that means we will also have a plus bi. And opposite, just like it says. If we have a plus bi as a zero, then the conjugate or the opposite of that, sorry, hopefully my dog doesn't bark because she barks very loud. Okay, so the conjugate is just the opposite pair. All right, moving on to our first example with the complex numbers. And when we say complex numbers, we're talking about numbers that include I. That's a complex number. Typically, they're written as a plus bi or a minus bi. That's usually how complex numbers are written. Okay, let's take a look at example 2. Here we have x equals 3, x equals 4i, and x equals negative 4i. So what we are going to do is we are going to write them using the same formula as above. X minus root 1, x minus root 2, and so on. So here's our root 1, our root 2, and our root 3. Let's set it up. X minus 3, x minus 4i, and x minus negative 4i. Here we are again with that double negative. Double negative means we have a positive. Now that we have our roots written, if we want to get back to the polynomial, we can multiply everything out. Multiplying everything out, starting with, let's start with these i's first. X times x is x squared. X times 4i is 4i x. Negative 4i times x is negative 4i x. And negative 4i times 4i, negative 4 times 4 is negative 16. And I times I is I squared. Now, what we talked about in a previous lesson, our first lesson about complex roots, we said that I squared is equal to negative 1. So if we were to rewrite just this little section here, we could rewrite it as negative 16. Instead of I times I squared, we can say times negative 1, which would give us a positive 16. So what we had practiced was canceling out the I squared and changing the sign, because that's all that's happening. The I goes away, and the 16 is now positive 16. So doing that, we can also combine these 4ix's, negative 4 and positive 4, that's 0. Those cancel out. So over here, we're left with x squared plus 16. That's interesting because here we have a sum of squares. And sum of squares uses what special letter? I. We have a perfect square here and a perfect square here. And look at where we started from right here. Interesting. All right, give me a second to clean this up and then I guess I could just hit that. Oops, too far. Okay, now we've done those two, so we need to bring down the x minus 3 and multiply that out as well. X times x squared is x cubed. X times 16 is 16x. Negative 3 times x squared is negative 3x squared. And negative 3 times 16, 16 and 16 is 32, plus 16 is going to be 48, so negative 48. Now, this is not in standard form, and we like standard form because standard form is nice and pretty. We write everything from highest exponent to lowest exponent. There's our polynomial. So we were able to take the roots and determine the equation of the polynomial. We can say y equals or f of x equals whatever. Whatever's fine. We had 3 roots, and look at our degree. X cubed. Our degree is 3. Let's take a look at the next example. Need to hurry it up. All right, example 3. We have 3 roots. So what do you think our degree is going to be? If you're guessing 3, you're probably right. So here we have our root 1, our root 2, and our root 3. So setting this up, I'm going to say, let's skip this one for right now. Let's set up the other two. So we have x minus 3i and x plus 3i. So when one of your roots is a fraction, this is a special case. So let's make a little note over here. When a root is a fraction, we treat it differently. How should we say this? We treat it differently. Need to solve. No, let's not say solve. Let's say need to set, set equal to 0. And I'll show you what that means. This is special case. No, I want to say solve, but you'll see why. Okay. Anyways, we have x equals 2/3. Now, this root is not x minus 2/3. That's not how the fractions work. It was not a fraction to begin with. It was a whole number. So what we need to do is slowly work backwards to bring these numbers back over to x. So we are going to multiply by 3 to get rid of the denominator, leaving us with 3x equals 2. Now we need this 2 to go away. We're kind of solving for 0. I know that sounds weird, but we are solving for 0 in a sense. So this factor did not start out as x minus 2/3. This factor is 3 times x minus 2. Minus 2, bring down the other factors. And then we can multiply everything out. But before we start multiplying everything out to get our original polynomial, I want you to see why why your root isn't a fraction. I know I had an example. Oh, here's one. Look right here. This polynomial, we factored it and we got 3x plus 2. When we set that factor equal to 0, we subtracted 2, and then we divided by 3. And look, it's saying x equals negative 2 over 3. So let's look back at that question we were just looking at. Here's our root. It says x equals 2/3. So the root wasn't originally x minus 2/3. Let's look back. We had subtracted the 2 and then divided by 3. So working backwards, we're going to do the opposite of division. So multiply by 3 and then subtract or add the 2 to the other side, getting us right back to that original factor, 3x plus 2. All right, let's take a look here and finish this one out. All right, so getting our equation, we need to multiply. Let's do the i's together. X times x, x squared. X times 3i is 3ix. Negative 3i times x, 3ix. And negative 3i times 3i is negative 9i squared. Now again, we said I squared is negative 1. So instead of saying 9 times I squared, we're saying 9 times negative 1. Oh, sorry, it's negative. Negative 9 times negative 1, which is a positive 9. So get rid of the I, make it positive. The middle two terms cancel each other out, leaving us with x squared plus 9. Now we still need to factor or multiply in this factor here. So now we multiply these out. 3x times x squared is 3x cubed. 3x times 9 is 27x. Negative 2 times x squared is negative 2x squared. And negative 2 times 9 is negative 18. Now writing this in standard form, here's our polynomial. And look at that degree. It was degree of 3, and we have 3 roots. All right, we have one more example that we need to get through kind of quickly. All right, we have 3 zeros here. So what do you think the degree is? Probably a degree of 3. So let's start by writing our equation or our factored form, just like we did in the formula. X minus, well, again, we have a fraction, so let's hold off on that. So we know we're going to have x minus 1 and x plus 1. Now, getting with our fraction, let's say x equals 5 over 3. How did we get here? We start by undoing the denominator, and now we need to subtract the 5 so that we can have 0. 3x minus 5 equals 0. So our factor here is 3x minus 5. Now that we have everything set up, we can go ahead and multiply it out. Let's start with the matching parentheses first. X times x is x squared. X times 1 is x. X times negative 1 is negative x. And negative 1 times 1 is negative 1. Now these two in the middle cancel out. And here we are left with x squared minus 1. Now to multiply in that first factor, we need to multiply. 3x times x squared, we're left with x cubed. 3x times negative 1 is negative 3x. Negative 5 times x squared is negative 5x squared. And the last one is negative 5 times negative 1, which is 5. Now to write it in standard form, our polynomial, let's say y equals, or f of x equals, whatever flows, 3x cubed minus 5x squared minus 3x plus 5. There's our polynomial. Awesome. Well, if you have any questions, please ask me or ask your teacher. Otherwise, we will get our worksheet done tomorrow. Have a great day.